All right, ladies and gentlemen, we are diving into our talk on 3.3 as we start really looking into the properties of logarithms. So the goals of this section are students will, in the end, use a change of base formula to rewrite and evaluate logarithmic functions. You use properties of logs to evaluate them, use properties to condense or expand log functions, and in the end, use properties of logs in real life as well, too. The purpose of this video specifically is going to be diving into the change of base more than anything. Now, before we go on, I want to do a quick little recap from some previous lessons, just to make sure that we're all on the same page here. So, behind all of these blanks, I have a little test for you. So pause the video, see if you can answer what's behind each of these blanks before we reveal them. Do it. Pause it now. So what do you guys think? What'd you come on up with? Log base A of 1, dun dun dun, hopefully remember that as being 0, because the only way to get 1, remember it's what number, or A to what number equals 1, right? What about log base A of A? So once again, A to what number equals A? Hopefully remember that being 1. Log of A, or log base A of A to the x. What do you guys remember from that? Same bases, thus we end up getting our exponent. What was behind here? Well, this was our second way to write it, and hopefully we recall that we could do it in a sense like this as well too, where we raise the base to a logarithmic exponent, and you get the same result as well. Now, finally, log of A, or log base A of x equals log base A of y. The only way this happens if what? Hopefully remember that x and y are the same in the end. All right, time to move forward a little bit. Change of base. Hopefully the change of base is not a completely new topic for us, but if it is, that's okay. It's fun. All right, it is a good thing to look on into. All right, so let a, b, and x be positive real numbers such that a does not equal 1 and b does not equal 1. It is true that the log base a of x can be written as log of base b of x and log base b of a. Well, why do we do this? Because calculators are limited. Now, I get it. So back when I was learning how to do all this stuff, they were extremely limited. Now I know there are some emulators and there's some calculators now that will do change of base automatically for you. Technology is changing, things are happening in our world, which is fantastic, don't get me wrong, all right? One, as a teacher, we cannot expect that every single individual has the most fanciest and up-to-date calculators. And two, I don't want to rely on a calculator for every single thing that we do either. I want to know where and why they come from. And so that's how we're going to learn this change of base formula, even though some calculators do it for us anyway. So let's take a look here, guys. So what do we do? So because our calculators go into common log for us anyway, we go ahead and say that log with base a, if it's not the common log of x, is equal to the common log of x over the common log of a. So that's where our change of base comes on from. And we can do the exact same thing using natural log, because the natural log is that exponential base, right? It's our base e, our natural base, which is exponential base, our natural base of e. And so since they have the same base, we can also make that change on there as well too. All right, so how do we use it? Let's simplify the expression using the change of base methods that we had just described here. So it says log base 4. So what I want to do, guys, is do both of these with our common logs, and then I also want to do both of them with our natural logs, just to kind of show the comparison between each of these. All right, so for our first example here, this can be written as log base 10 of, equals log base 10 of 30 over log base 10 of 4. And in your calculators, guys, just make sure that when you're substituting these on in, actually we can do it real quick. I have one up and ready to rock and roll. So we have log of 30, and we are going to divide that by log of 4. All right, and we get 2.454, or 2.453 in this case. So 2.45. All right, but for this one, log base 10 of 14 over log base 10 of 2. And once again, in our calculators, log of 14 divided by log of 2, and we get 3.81. All right, guys. So again, see how easy that is. Another change of base just like helps us out so much. All right, basic logs using the calculator function. Super simple to deal with all of these specifics. But what I want to do is now take this into a natural log. All right, to do the same thing, I want to use our natural logs instead. For me personally, I always tend to do the natural log. I don't really know what it is, not really a reason why or the other. Just the natural log for me just seems more natural, no pun intended, okay? So for our first one, part A, we would just simply say, hey, it's the natural log of 30 over the natural log of 4. For part B, we would say that's the natural log of 14 over the natural log of 2. Let's take a look here. So in doing so, the natural log of 30 over the natural log of 4. And same thing, 2.45. And obviously we'll see the same thing for natural log of 14 over the natural log of 2. Same thing, guys. So both of them work. Again, for me personally, I always like using the natural log just a little bit more. I can't really tell you why I do or don't, but it's just kind of one of those things. All right, guys, that's going to wrap up our conversation of change of base. In our next video, we are diving on into the properties of logarithms that will help us expand and condense some expressions.